Welcome to the Nuix session, where we're going to talk about Nuix for Zero Trust. And of course, we're focusing on insider threats, data governance, and just generally how we're addressing Zero Trust. Really, the point of this presentation was kind of to map Nuix to Zero Trust requirements. So if you're not familiar with Nuix, it'll be a good chance to see like sort of what the laydown is of our product against Zero Trust. And we'll also kind of dive deeply into insider risk, and specifically what we're doing around insider risk. So my name is Hope Smith. I'm VP of Cybersecurity at Nuix. I've been in the company for 9 years, and I work a lot with our customers on insider risk, implementing our products to detect risk, and more recently expanding from user activity monitoring into full scope investigations of insider risk using But what I wanted to talk about today was really to kind of go through insider risk, to focus on that for a bit, get our minds around that, then apply it to Zero Trust and look at what Zero Trust can sort of tells us about insider risk, what are the different capability areas that are applicable, and then drilling into 3 of those to look more specifically at user activity monitoring, which is our agent-based means of detecting malicious activity, of detecting misconduct and responding to that on the fly. And then in the 4 and 5 items here, we'll be looking more at investigation. So we'll pivot from detection, real-time monitoring, and talk in depth about investigation. And we'll look at applying automation to investigation. So where you, of course, I've heard of security orchestration. This is our application of orchestration and automation to a portion of the security value chain, specifically around investigations. So we'll go through that, and then look at artificial intelligence and what we're doing in terms of, particularly in terms of machine learning and understanding sensitive data using artificial intelligence. And then finally, we'll touch a bit on getting proactive. So most of what I will be sharing today is around detection and investigation, or detection, triage, and investigation, responding to malicious activity. But at the end, we'll talk about how to get proactive and what are some ways to use this technology to get into more of a preventive mindset and a preventive posture. By the way, we can keep this very informal, so if you have any questions, please interrupt me, but I don't want to put you on the spot either, so I'm happy to just run through the material. So yeah, just if you look at the data on insider risk, it's actually hard to find good data on it. Not surprisingly, most enterprises don't really want to talk about the compromises that they've undergone. They don't want to talk about whatever bad things that have happened, because that compromises their brand, it compromises their reputation, their value. But there is some quantitative data out there from surveys primarily of security teams, and that'll tell us that the cost of incidents appears to be increasing, the number of incidents appears to be increasing, and I think probably most interesting is the amount of time it takes to contain an incident. So it is now taking somewhere almost 3 months to detect and contain an insider risk incident, an insider risk event, which is always brings to mind to me sort of the journey that cybersecurity took from going from a similar period of days. I remember when Mandiant first started reporting how long it took to detect what the mean time to detect a threat was. It was over 100 days. And now that's gotten down into the minutes. Like if you were talking to security vendors or managed service providers around security, they tell you that they could detect cyber threats in seconds or minutes and probably contain the cyber threat in less than 10 minutes. With Insider, it's a little behind. It's basically the problem. I think hasn't been received the same level of attention that cybersecurity has. So it still takes a very long time to contain an incident, which is part of the driver of the cost.
Is that 85 days from the day of detection?
It's the time to both detect, and so containment would include, isolating, detecting, and then isolating and stopping.
Okay, because the containment isn't until after it's been detected, even though you
Exactly.
contain. Right.
Exactly. Yeah. So you've got to get through detection, and then you have to know enough about what's happening to actually contain it, keep it from spreading, stop it. So, who knows, maybe what the numbers are really, what the numbers really mean. But when you look at where security programs actually are spending their money, Insider is actually the #2 priority in terms of security initiatives. Begs the question, what's the #1 priority? Or what's the #1 driver? And it's policy changes, so policy like GDPR, CCPA, those kinds of policy things that are causing security programs to start new initiatives. But insider risk is #2, and I think it's because, again, it's received less attention than cyber has. So you might ask, well, why? Like, why would it be increasing? What's going on? And I think there's a couple of reasonable conclusions about why. And the first is that, as we know, most large organizations these days are treasure troves of not just intellectual property, although that is a big component, but also personally identifiable information about customers and about employees. And that data can be sold. The IP can be commercialized. And then there's other categories of data too that you wouldn't think of as necessarily having market value, but might have value from a blackmail standpoint. So if you think of email, if we go back to the Sony compromise and what the North Koreans did to Sony some years ago, they disclosed emails from Sony that were about A-list actors. And it was very embarrassing. It caused a lot of brand damage. So tons of sensitive data. It's getting easier to sell it, and that's in part due to the presence of these marketplaces on the dark web that make it quite easy to both post or dump customer data, but it's also because of cryptocurrency and the ability to take payment, make payment more anonymously. And in fact, one of the insider threat cases, we'll talk a little bit about, we'll get into how cryptocurrency came into play in that specific case. I think there's also some indicators that like people's attitudes are changing. Like some of the survey data says that millennials, for example, feel less allegiance essentially to their employers. They're more willing to take data that they've been working on if they've been working on a project. They have less concerns about basically taking it with them when they leave their employer. They don't think of it as their employer's data. You also see in the classified world, you see mindsets have changed around, am I working for the good guys or not? Am I working for the good guys or the bad guys? And so the Edward Snowdens, the reality winners of the world, had concluded that they didn't feel that it was immoral to disclose classified information. And then you have the Jack Teixeira case where he had sort of different objectives altogether in terms of what he was doing with the data. So I think there's some indicators that people's attitudes have changed a little bit, and they're less protective, basically, of sensitive data. And then finally, on the incentive side, I think probably the financial incentives aren't new for selling data, but it's now easier to commercialize stolen intellectual property, particularly in China. You can take IP and go and start a company in China, and chances are your American employer or your Western employer won't actually know about that. And a good example of that happened recently with a Google engineer. So there are some differences in the incentives and a number of drivers of what's changing in terms of insider threat. So speaking of Jack Teixeira, he was Air National Guard specialist, but just an IT specialist. He was not like an intelligence analyst, but he worked in an intelligence squadron. And so he had access to intelligence reporting and intelligence analysis. And he was told, actually, when he started there, they said, you need to make your customer's mission your mission. You need to understand, like, you shouldn't just be going through the motions of IT administration for your command. You need to understand, like, what it is that they're working on. So he's reading intelligence reporting. And he started to print that intelligence reporting out and walk it out of the building. And in some cases, he was transcribing intelligence reports and just walking his notes out. And that included stuff that was at the TSSCI level. I believe a lot of it was related to the Ukraine war, and walked it out. What was his motive? It's quite interesting. I think the best analysis I saw of Jack Teixeira's motive was the Washington Post work on that case. Basically, he was trying to build credibility on his Discord server. He wanted people to think that he was in the know, and so he used classified information for that purpose. Wasn't trying to make money off of it. The Jonathan Tebbe case, this is going back now about 3 years, I believe. This is a quite interesting one. Carrie and I were talking about it a little bit just a few minutes ago. Jonathan Tebbe was a nuclear, very, very intelligent guy. He had 2 master's degrees, one in physics, one in nuclear engineering. His bachelor's was in an easy topic like math. And he was on staff in what's called naval reactors, which is the office within the U.S. Navy that oversees the operation of nuclear power reactors on ships and submarines. And so that's what he went after in terms of the data that he was targeting, was technical data on how reactors work, their specifications, what their tolerances were to various conditions. He printed his documents out and then walked them out of his facility, and ultimately mailed information to a foreign intelligence service. But in the mail package that he sent, he included a Proton Mail email address, and used that to set up a secure communication channel with the handler. Here's where the cryptocurrency comes in. So he had done his research on cryptocurrencies. He had looked at Bitcoin, but decided that Bitcoin was too traceable, but that Monero would give the kind of anonymity that he wanted, and that would be a safe way to be compensated for providing classified information. So his motive was purely financial. He had 2 kids, he had them in private school, had a lot of costs that he was struggling with, and so this was primarily financial motive. It did come out at the time that he was angry at the presidential administration he and his wife were, so that possibly played into it, but if you look at exactly what he did, he was looking to make money. The very interesting thing about this case is that he mailed this information to a foreign intelligence service, the Brazilian intelligence service, who immediately turned it over to the FBI. And so he's waiting for a Proton Mail message from the Brazilian Foreign Intelligence Service. He receives a message from who he thinks is them. It turns out it's the FBI. And they say, well, what sort of information do you have for us? And he provides a sample, and they say, that looks great. We'd like you to drop it in the park at X location at X on Y date. And he says, oh, no, I'm not going to physically meet you. That's why I gave you the Proton Mail address and the Monero account. You're just going to deposit the Monero, after I mail you the stuff on Proton. And they said, oh, that sounds great, but our procedures don't allow for that, unfortunately. We'll have to meet you face-to-face. We have to be a physical meeting. And so it goes back and forth on this. And he says, how do I know that you're not a U.S. intelligence service? That's his question. And so finally he says, if you're able to put a flag in the window of the Brazilian embassy on Memorial Day, which is when I can be in Washington, D.C. for vacation, then you must be the Brazilian Foreign Intelligence Service and not any U.S. security agency. Well, the FBI went to their Brazilian colleagues and convinced them to put the flag up in there. And so he saw that. He concluded that he was indeed talking to Brazil's intelligence service and agreed to the dead drop. So, and then he did a couple of dead drops. They photographed this, the FBI did, and then arrested him. So I know I paused a bit on that one. That's quite an interesting case. Leon Ding is the Google software engineer who was working specifically on this technology that Google had to use data centers to apply entire data centers to training AI models. So they had figured out how to run GPUs at scale to train AI models. They had learned a lot from working on that for a period of years. And he said, well, I can start a company in China to do the same thing, essentially, in the local market. So he copied data out of Google Docs to Apple Notes, saved those as PDFs, and then uploaded them to his personal Google Drive account. Of course, he was looking to start a new company in China. When they arrested Leon Ding, he was both the CTO of a Chinese company that another guy had started, and he was actively pitching that company's technology in China, and he was the CEO of another company that he had started. So he was really busy outside of his role at Google. He was actually working in China and didn't tell Google that he was working in China. Didn't want to take vacation time. So he had a colleague use his badge to walk in and out of the Google facility. Okay, he should have just taken vacation time. So Leon Ding. Most organizations, so let's pivot here and talk about what organizations are doing about this. We work a lot with government agencies and with banks, with large corporations that have investigative functions and capabilities. And in general, they're going through a workflow like this. It starts with detection and alerting around insider risk. A lot of times that will take the form of data loss prevention, DLP technology. In general, those tools are generating a lot of alerts because it's very difficult to distinguish authorized user behavior from or behavior that is authorized. Technically it's authorized, but it's malicious or it's misconduct. It's difficult to distinguish that a lot of times from not misconduct, from authorized activity that's legitimate. It's somebody working hard late at night on a high intensity project. So triage is a way of distinguishing smoke from fire and figuring out which of those alerts are in fact misconduct. Once there's a determination that yes, there is a problem, there's usually a collection of additional data. So if the person has maybe the endpoint monitoring has picked up a flag on Hope, the next step is to collect from Hope's OneDrive or from my email, and so that's going to involve sources, collecting from a range of sources and then examining that data to determine whether or not additional action needs to be taken. And then from the collection stage, we move into processing, searching and tagging the data, visualizing it for collaboration, potentially export, and then in some cases legal review. Most enterprises don't have this full scope, this full value chain, certainly not on a single platform. But that is one thing that Nuix offers, is the ability to go all the way from an alert through a legal case. In most cases, you're not going to see a legal case coming out of this, but sometimes you will, and that's why it's very helpful and important even to have the full sort of forensic chain behind that basically starts with the alert and pushes all the way through to legal review. So there are some pain points that are generally associated with this process. And the first one is that risk detection internally is usually inadequate, so people don't really have visibility into what their users are doing. When we go in with our user activity monitoring stuff, generally it lights up, people light up with, wow, I did not realize that there was this level of data moving around, that sensitive data was being uploaded, copied to media, that people are running software they're not supposed to, a number of different sort of things that we see that the light goes on. So internal risk detection, problematic. Once you get into the collection phase, a lot of times that's going to mean interacting with Microsoft 365 services, purview, for example, and that tends to be a cumbersome process if you don't have a way to automate it, if you don't have a way to streamline it. And then manual initiation of processing. So if you do have a large amount of data that's been collected, if you've collected somebody's computer or sources, maybe their email, then initiating that processing and shepherding it through the different steps of processing it can be time consuming and can basically drop time on the floor. So somebody kicks off a job at 3 p.m., leaves at 5, and then the job finishes at 5:30, and they don't actually get to push it through to the next step till the next morning, so time gets lost that way. Then manually searching for sensitive data is one that we're dealing with a lot right now with customers who have these big piles of unstructured data and no way really to know at scale what's in it. And this is where artificial intelligence comes in, that we'll look at in a little bit. And finally, no single platform for disputed matters. So if you do end up in a legal case or needing to provide data to a regulator, having all of the information, again, starting with the alert through the triage activity and all of the different steps in the value chain here that were executed to analyze the data, having all that in a single case becomes of great importance. So this brings us into Zero Trust. The way that I looked at Zero Trust for this presentation was through the lens of the DoD CIO's Zero Trust overlays. And I don't know if everyone is familiar with that, but in general, sort of at the very highest level, there was an executive order 14028 that sort of came out of the Colonial Pipeline events that in which the president said we need to move to a Zero Trust footing within the U.S. government. The Defense Department put out a Zero Trust strategy. The strategy identified these pillars that were sort of the next step to the capabilities that agencies need to have in order to address Zero Trust. Actually, before that existed, there was NIST 800-53, which specified controls for privacy and security. And that kind of brings us into the overlays, which brought those two together. So we have the pillars identified in the Zero Trust strategy, the security controls in 800-53, which gives us these Zero Trust capabilities across 7 areas, where you have generally the sort of components of an enterprise: the user, device, the application, the data, and network. So you have those sort of 5 components. And then you have a couple of things that generally need to be done in order to secure the components, which include automation and orchestration there, and visibility and analytics. And then, since it's the DoD, we've got .mlpf down there at the bottom as an execution, a series of execution enablers. So where does insider risk fit into this? And specifically looking at detection, triage, and investigation. And so actually it's all over the place. It really kind of, user activity monitoring, it lives under the user pillar in the behavioral contextual ID and biometrics capability area. But if you look out over on the far right there under visibility and analytics, you see UEBA down there, you see traffic logging, and then coming back towards automation and orchestration, you have a number of different automation capabilities that bear on insider risk. Of course, data loss prevention, which is the first line of defense in general against insider risk. When enterprises are thinking about insider risk capabilities, oftentimes data loss prevention is the first one that they'll implement. Under application or workload, we have continuous monitoring. And then on the device level, we certainly have device detection, but then we've got a couple of things that bear directly on endpoint management, device management, MDM, and XDR and EDR. So it's interesting when you look at Zero Trust and you see that there's quite a bit of reference to insider threat in the language, but Zero Trust, as we know, was really conceived of as it's a cyber defense framework primarily. However, it has a lot of bearing on insider key, you can see here. Okay, so drilling down into user activity monitoring, we've got a couple of different things that Nuix addresses through our user activity monitoring capability that I'm going to demo here. We've got certainly the UAM specific functionality that's called out in 1.6, but device detection and compliance is another thing that we address, particularly when it comes to at least one aspect of it, when it comes to removable media. So that removable media is a big device issue when it comes to insider risk. And with our capability, we're able to detect unauthorized devices and then the misuse of those devices. From a DLP standpoint, we offer some visibility into data movement, so we're more of a data loss monitoring technology than we are a prevention technology. And then logging, we actually do log about a dozen different categories of endpoint telemetry, and we're to some degree playing in UEVA based on the user activity and user telemetry that we generate on endpoints. So what do we actually do? We look for, in our UAM solution, we're looking for data removal, which is kind of the culmination, oftentimes, of an insider risk scenario. But there's a number of precursor activities that are occurring in insider threat use cases and insider threat situations. And when you talk to people about the state of the art of this problem, they are in general looking to get more preventive or predictive. And in order to do that, you have to kind of step back and look at what are the precursors, what are the associated, what are the user activities that are associated with data theft, and detect those. And so one of those would be data collection. So the person is, like in the Jonathan Tebby scenario, he was over a series of months visiting various intranet sites and shared drive locations and acquiring data related to reactor operating manuals prior to actually removing that. Data arrival is something that we're also asked about a lot these days, and this is just kind of the presence of classified data or the presence of sensitive data that shows up not necessarily out of malicious, maybe there's nothing malicious going on, but a person has accidentally downloaded something classified to a machine that shouldn't contain classified, or they have received information that legal action prevents them from being authorized to have, in a case we saw recently. So data arrival, another category. Data deletion, unauthorized browsing. Believe it or not, in this day and age, people still do use their work computers to browse to internet sites that they should not, and that can be a indicator of other issues. So we recently saw one where the unauthorized browsing was actually triggered a closer look, which revealed that the person had another job. So it was a dual employment case that came out of browsing to adult sites on work computer. Unauthorized software is a big flag that we see a lot, and labor claiming, data mishandling, workplace violence. Workplace violence is one of the sort of major objectives of U.S. government insider risk programs, and so the ability to detect people discussing suicide or bringing weapons to work or contemplating violence is something that is a high priority for a number of them. So there are a number of features in the Nuix product, and I've kind of made reference to a good bit of these. I won't go through the slide here. I think I'll just pivot over and I'll start with a couple demo scenarios. So the first demonstration scenario is data theft. So the person is moving controlled unclassified information to personal webmail. So let's just take a look at that. This is what the, so there's a user console application in adaptive security in our UAM product. There's a console application that an operator or analyst uses to receive alerts. And so that's what we're looking at here, is that console application. And as alerts as users trigger alerts, they will appear down there under latest alerts. Up in the top left is a count of those alerts by severity. And then we have status of endpoints that are connected up in the top right. So there was a filter view on, and the filter was removed, and now we're looking at only alerts that have not been assigned to anybody. There's some alert workflow here. And pivoting over to the bad guy's machine. So our bad guy is looking for sensitive data in a folder on his desktop, scrolling through till he finds exactly the file that he wants, the graphene paper formula, which he drags over into Google Drive. And this could be Gmail or any other file sharing site or personal email site. These are cropping up all the time, of course, and users find various ways to get to them. And they make it quite easy to move sensitive data around, because usually you can't completely block these websites. So this user is actually also copying to a removable media device. He's copied that same file to a thumb drive. The endpoint agent is going to send back alerts, and so in the console view here, as soon as the operator refreshes the view, you get these 4 alerts. And those alerts are the first one indicating that a user uploaded sensitive data to webmail or file sharing site, and that screenshots were captured. And the second one indicating that sensitive data was uploaded and a copy of the file was collected. And so that's what we're looking at here, is an alert that indicates a browser event. And a browser event is where we've put together on the endpoint. We actually applied for a patent to do this. It's unusual to be able to do. We've put together the user's browsing activity, so they had browsed to drive.google.com, and then the upload of a file with the browser. So the browser is opening a file up, and the person was pointing the browser to drive.google.com. The endpoint agent brought those 2 things together into this event, which shows me that Ed Manning uploaded graphene paper formula to drive.google.com. And we can do that without hooking the applications, so we get much less CPU, RAM consumption, footprint on the endpoint by taking that approach. Keep it going. So in the file collection, we actually inspected the document, so opened it up and looked for regular expression matches. There's one to controlled unclassified information, and that's how we knew it was sensitive. Once the endpoint agent recognized that it was sensitive, it took that additional step of making a copy and bringing it back to the console application. And once it's in the console application, the operator can download it for further examination if he or she wants to do that. Now this alert also captures screenshots. So when the file was uploaded, and again, the data was scanned, the document was scanned, found to contain matches to regular expressions. The next automated action that the agent took was to take screenshots of the desktop. So you remember before, like we were looking at the bad guy's screen. Now we're not looking at the bad guy's screen. We're actually looking at a sequence of 240 screenshots that were triggered by that upload move. And they're paused right here. The screenshot playback is paused on the upload. So one of the things that's unique about this product is its ability to capture screenshots that capture user behavior that occurred prior to the triggering event, as well as after the triggering event. Okay, any questions?
How did it know to start recording?
Oh, that's
They just open a browser to, say, Google Drive, but obviously it started recording before they had even grabbed the file and dropped it. So what triggered that?
The trigger was the opening the browser.
So any browser, or is it specific?
Yes, no, it's any browser, but so there's 2 triggers. There's a trigger of like the screenshotting taking place, and then a second trigger to get the screenshots. So the guy opens the browser up, the screenshotting starts,
Okay.
and it's kept 60 seconds of it are just continually maintained in their rolling file. But those will just continue to just sit there, nothing will happen to them until a second trigger occurs, which was the sensitive data upload. So he uploaded the file, and then the agent opened up that file and looked for sensitive data inside it.
Oh, I got it. So it didn't capture it, it kept it, and it pulled those screenshots forward. And said,
Exactly.
here it is. Okay.
Exactly.
So you're always being watched, regardless of doing bad things or not.
You are. I mean, it's a risk, it's sort of a risk management. I mean, yeah, it's like, it's a legitimate concern. The risk.
told you not to.
Yeah, I mean, I think the approach of like leaving the screenshots on the system and only pulling them back if the user breaks the policy is a way of sort of striking a balance between the privacy
No, I love it, but I'm just
implication.
saying.
Yeah.
I mean, I
Understanding what the mechanics behind it.
Yeah, one thing I just to insert real quick. So the tool being shown here is called adaptive security, and I will be the first to admit that Nuix has amazing technology, but we're terrible in our products. That one we actually got right, because it really puts the granular control into the operator's hands to adapt the rules, the usage, the tuning, and everything else to suit your needs, even to the ability to have multiple sets of those for different user groups. For example, you've got one for this squadron that happens, this is their sort of standard home-based operational tempo, this is what's going on.
Right.
Well, then they're going on an exercise. Well, you need to apply a different rule set
Yeah, you
to
ramp
those
up.
machines, those users, because now they're doing stuff, say at 2 in the morning when they normally wouldn't be doing that. You don't want to see a bunch of alerts based upon normal activity. So it gives you the ability to do that and write those rules or tweak existing rules without coming back to this.
Thank you.
No, thank you. It was a great question. So this is just showing that we can download the file. So we made a copy of that file that was uploaded, and the operator now wants to go and look at that and say, oh, is it, what exactly was this? Or maybe just maintain a copy of it for the case. Right, as I was recording the video, my colleague Alex called me on Teams. So the lesson learned is to shut down Teams before you record a video. When we do perform a collection, we create a manifest of what was collected, and the little collection manifest shows you the file name, also the MD5 hash of the file that was collected, and then the MAC time data from the document. And the document itself is actually included in that collected zip file. All right, so that was the upload and copy to media. We talked a little bit. The copy to media functionality is very similar. It's making a copy of the file that the person put onto the thumb drive if it contains sensitive data. So the next scenario is that collection problem where the person is trying to assemble a bunch of data to move outside of off their work computer. And so a couple of scenarios to consider here. One of the most powerful tools in the product to deal with this is clipboard monitoring. So whenever there's a copy, a Control-C, a Control-V, right-click copy, right-click paste, the endpoint agent creates an event for that. And the event consists of the process that sort of originated the copy that the data was copied from, the destination process, and the window titles in both cases. So what was the window that was up when they copied the data, and then what was the window that was up when they pasted it. And that all gets assembled into a clipboard event. The clipboard event will capture string data, if that's what was copied. And so there's an example right there with a highlight where it says that it's a clear white substance. That was a Control-V of a string of text. And it also will capture an image. So if the person had done a copy of an image from a PowerPoint into a Word document, it would show that. That was actually earlier in the video here. So we can use that from an alerting standpoint to, you know, detect and notify us to problems. So in this case, we've got a research report that's a PDF that has got controls on it that will know if somebody tries to move this file around. So the user's just going to copy the data out of the PDF into a Word document. Well, Adaptive will notice that you have watch-listed data being copied from a PDF over onto a Word document, and it will take a screenshot. So here what we'll see is a screenshot sequence of the copy and paste. Notice that this time we did 240 before, and that was to capture, you know, 30 seconds of activity before the triggering behavior and 30 seconds after. In this case, I don't need a whole bunch of context. I just want to see the two files that were involved in this paste event. And so 5 seconds of screenshots works, and as Carrie pointed out, the rules framework allows the operator, gives operator control over that. And in this case, it selected 5 seconds rather than 30 seconds. The event data includes, you know, sort of with the alert actually has event data on it, including that clipboard activity. The second scenario is one that came out of a financial services customer. These guys have a web application that contains their customers' account data in it, and they have account reps who periodically will copy that data out and store it locally. And so they alert whenever that happens, whenever there's a paste from a browser into a local file, and that allows them to monitor for people trying to steal data, either to sell it or potentially to make personal use of it. They had people who were actually you know, taking account data and then going and withdrawing money from the account or making other transactions that were to personally benefit from the account data. So anytime that account data is extracted from the web application, they want to know about it. And that's what this is able to do. This alerting is able to detect that.
Would it trigger if you printed a web page too?
If you
just printed that web page, which would have the account data in it too?
You could set it to do that. Yeah, you certainly could. So there's the alert account number copy from browser and screenshotting, and so again, we'll get a smaller number of screenshots on that kind of activity than we would on a you know, an upload scenario. So this is the clipboard event data. This is that specific event. I think what I wanted to show here was that I mentioned earlier that images are also included in these clipboard events. And so I think the top one there is an example of an image paste from PowerPoint into Word. And so when the user clicks on that, they'll see that image there. So that's exactly what was pasted from PowerPoint over into Word. Okay, last scenario is around workplace violence. So as I mentioned, this is, you know, sometimes it's like the number one or number two objective of the insider threat program. It's, you know, data theft or disclosure, and then workplace violence. And so we can use keystroke monitoring to alert on indicators of suicide or other concerns around violence. And where this gets, I think, more relevant is when you have a scenario like this one where our user is talking about one of his colleagues who's discussing suicidal thoughts. He doesn't feel comfortable sharing it with a coworker, so he's actually talking to a former boss, sending an email to a former boss. The problem is that this particular individual is about to be given expanded access. His access to physical facilities is about to change. His access to information systems is about to increase. So this becomes, you know, something that an insider threat program needs to be aware of, needs to focus on. And the endpoint agent has detected the use of this term suicide and has created an alert around that, which will allow the operator to triage that and decide whether or not additional action is necessary. And so you see that high priority workplace violence keystrokes have been detected. And then that is the screenshotting sequence you can see there. That's controlled by the rules framework, so it's called the engine filter language on the endpoint. And so you can see that there. It's basically like a scripting language that the operator uses in order to cause these alerts to fire. And you do have a fair amount of control over keystrokes, like how that happens. So I might want to know, for example, if the term, shoot was used, or shoot me, but I don't, or the term shoot me, the phrase shoot me, but I don't want to get an alert if it's followed by an email. And so that's one of the things that the language allows you to do, is to include shoot me, exclude shoot me in email. And there are a number of different tools that are available to control for false positives and to focus in on the key issues with the keystroke monitoring. One of the useful things about it too is that, unlike monitoring the text of emails or something in Outlook, this would be the keystrokes that are entered into other applications, chat applications that the users install, maybe the enterprise chat application, whatever. Okay, so that wraps up the UAM adaptive security piece of this. And now I'd like to pivot and look more at investigations and what we're doing in terms of AI and automation. Before I do that, any questions on the UAM stuff? Greg has seen this once before. Okay, so automation. So now we're back into Zero Trust, looking at pillar number 6 here, automation and orchestration. And there's a capability for critical process automation, then one specifically for SOAR. So this is going to fit more into SOAR, although this is we're focusing on an aspect of SOAR specifically around investigations. This is where a Nuix product called Neo comes in, and Neo includes the ability to index and process all kinds of data, to prepare that for search, to tag it. But then most recently we've added some really exciting functionality around artificial intelligence to the term that we're using right now is enrich that data, to sort of value add to the data by applying natural language processing and other AI technologies to unstructured data in order to train it to recognize document types and topics that are of concern. And so I'm kind of focusing today on sensitive data and using AI to characterize sensitive data. Once we've enriched it in the Nuix Neo platform, then we can actually put together this case file, which consists of the full content of the data as well as these additional tags, this additional enrichment that we've executed with AI, and we will present that to the user using Nuix Investigate. There are 3 main use cases right now that we are applying Nuix Neo to. The first is data privacy, which essentially means identifying personally identifiable information and data that may have been breached, advanced investigations of all kinds, and then our legal solution, which is supports our e-discovery pipeline. So that's an overview of Neo. If we look a little bit deeper at the component of Neo that used to be called Rampiva. So Nuix acquired Rampiva April of last year, so a year and a half now. And it's been, since I've been at the company, probably the most insightful or intelligent acquisition that we've made in terms of the quality of the product. Even as it came in the door, it wasn't something that we had to do a lot of additional development work on. And the relevance to problems that our customers have. It's designed to solve pain points in that workflow that I showed earlier, and to address a number of things that cause customers headaches when it comes to investigations and e-discovery processing. And some of that you can see sort of, you know, some of the standard workflow steps that you would go through in the context of performing an investigation or preparing data for a legal case. Involves things like collecting data from individual users' computers, collecting it out of Microsoft 365, configuring the actual settings that are going to be applied to each of those types of data as they're processed into Nuix, adding them into the case. Sometimes we'll use digest lists of MD5 hashes or other criteria to tag data as it comes in. And then multiple other steps here that are involved in these workflows and processing. One of the more interesting ones for us in the demo material is optical character recognition. So if we have a PDF or an image that contains text in it, we wouldn't be able to index that without running it through OCR. And typically that means like we ingest all this data, we process it in, we identify which things need to be OCR'd, they go back through another processing step to be OCR'd, and if you had to do that manually, it would extend the amount of time that it took to work the case. But with automation, we can just program that to all occur automatically.
One piece I'll add real quick from the use case perspective is, you know, especially in a zero trust perspective, data preparation takes on a whole different meaning, especially if you listen to what the CIO talks about in terms of data preparation, which is sort of that other half of how do we get to ZT compliance quicker, easier, and it's one half is what Xage talked about earlier around the identity access control, secure remote access, those sorts of things. But until you have good provenance and understanding contextualization, categorization of your data, you don't know, right? It's one thing to have device access control and system access control, but then you've also got the data access control, and so you have to understand what that data is to be able to sort of match those up and say, okay, this user can access this file or they're allowed to copy it. So that's another use case of this, is to be able to, at scale, ingest massive amounts of data in an automated fashion, and then leverage the NLP, which is a no-code capability where you don't necessarily need a data scientist to actually build your models. You dump in samples and build your scoring, and so then it can very effectively go through and apply tags, for example, finding CUI that maybe wasn't tagged properly, you didn't know about, adding other context and categorization to items, so you can very quickly build that governance around your data, which then helps you know what's sensitive, what isn't, what is open to everyone, what do we want to protect, what do we want to move, what do we want to monitor differently.
So this is tagging everything in your current environment. It's not waiting for an incident to happen. Just saying that if an incident occurs, then you're ready to respond to it because everything has been appropriately tagged.
Yeah, and you could actually do it both ways, and so that sort of preemptive preparation of tagging everything just makes, you know, I remember a colleague of ours used to, in one of his blogs about insider threat, talked about sort of the best mitigation to insider threat and handling an incident is preparation ahead of time, information governance, and sort of cleaning house, knowing what you have and where, right? And you know, if you take that approach of all real threats that can hurt us, especially from a data perspective, are insider threats, because even an outsider would have to become an insider, short of a DDoS attack to really hurt you. And so if you take that approach and say, okay, I want to understand my environment at a digitally forensic level, right? I want to know every 1 and 0, I want to know the categories, I want to know everything. Then it's much easier to control things and apply your policies in an effective way.
Then you could apply DLP and other measures because the data's already been identified.
Yep, absolutely.
And create rule sets on it.
Exactly. And I think, you know, to your point, so we've had AI for a while, so we've had the ability to know what the tags should be, but the addition of automation enables us to kind of run that at a much greater scale than we could in the past. So what does this workflow look like if you were going to do, like, for automated incident handling? So what are we automating? So we're automating from the collection, basically this is triggered by the collection. So we'll start in the UAM tool. That will trigger a completely automated workflow. So it'll be 0 clicks, essentially, from when the user, the operator user initiates the collection in the UAM tool to when an analyst receives a report saying, you know, we've scanned thousands of files that a user uploaded or that were targeted in this collection, and here's the risk score of that data. Here's how that data scores out in terms of a sensitivity and risk standpoint. Okay, so this looks familiar. We're looking back at the UAM tool where the analyst said, oh, that guy uploaded that sensitive document from a folder on his desktop, data folder on his desktop. What else is in there? Did he collect a bunch of stuff over the last few years? And so the analyst is initiating a collection on the endpoint. So he's going to specify some basic collection parameters, like the location of the data, if there are MAC time parameters, like when the file was created, or maybe constraints around file extensions, and specify those. That's what's happening here. There are no constraints other than the file path itself, but if there were, they would be added here. And then the next step is to specify a collection destination. And so the endpoint agent could collect to the target itself, could collect to a network share, could collect to the adaptive security database, or could collect to an Amazon S3 bucket. And if the collection destination is an S3 bucket, we can use that to actually trigger the automation to process all this data. So in the course of creating the collection, our end user has to specify some information about the S3 bucket, including the identity of its access key and the secret key itself. And that will allow the agent to access the bucket and create a new bucket object consisting of all of these collected files. All right, it's not very exciting. Okay, this user will then see in the console here a status of that collection, and after a little bit of time, this is about a 500 megabyte collection of several thousand files. It will show up in this list as finished, and once it's finished, there will be a S3 bucket object with all of the files inside. And there's the bucket, so now we're over on the EC2 console here looking at this bucket called AS Collect 1, and there's the object that was created in the bucket. And this is the sort of exciting part, which is where Nuix Rampiva received a notification that that happened and immediately reached out to the bucket and began processing the data into Nuix and into this processing pipeline. So to access Rampiva, you're going to come into a web application. It's all nicely web enabled, and we'll look at a particular workflow here. This is the workflow in the automation application that controls what happens to that collected data and how it gets processed. And it's asking me to create a copy. And so the steps you can see down the left-hand side, these are the operations that the workflow engine executes to automatically process this data. And up at the top is the kind of standard stuff that an analyst would have to go through in order to repeat this process and to make sure generally that they're following the same process each time. Repeatability is a key part of defensibility. So in the first part of the script, the workflow engine is, not the first part of the workflow rather, the engine is executing a Ruby script, and the Ruby script is parsing out information from an incoming webhook to know where to acquire the data from. And then it's going to configure parameters around the case and add evidence to the case. This is all stuff, again, standard things that in the past our users would have to do manually each time one of these collections happen. Now it's all automated. There's PowerShell sort of kicking off as a new collection was initiated, which I was doing while I was recording this existing one, or looking at this existing one. Now we're down into the OCR, so we talked a little bit earlier about how Nuix will perform OCR on data, and that's what that step specifies. It says, okay, if it's an image file, run it back through the OCR process so that we can extract text from the image. One of the final steps is to create a sensitive data report out of this workflow. And that happens at this stage here, so where it says analyze items with Nuix NLP. This is the step that says, okay, apply AI to classify this, or to enrich it, as we like to say. And then once we've enriched the data with NLP, we will tag it. So we're sitting, the full content of the original processed item is sitting inside a Nuix case, a copy of that item. And once the artificial intelligence says, this looks like it is sensitive data, we'll create a tag and apply that to the item in the Nuix case. And then all of that actually gets rolled up into a report, a sensitive data report, that is in Excel format. And from that Excel document, an analyst can see what the score, the risk score of the sensitive data is. So that's what we're looking at here is the AI has risk scored 1,200 files and said, this is the top risk in terms of classification markings and other indicators of sensitive data. And what is a big leap for us was that an analyst who's looking at that risk score report can click on individual links in the report and jump into those items in the case management or case analysis tool. So now we're looking at Nuix Investigate. Investigate is the environment where the analyst can go in and search all of this data, add additional tags to it, can view the tags that were assigned to the items by the AI, can use this tool to export data for additional review or to other sources, and also has very powerful filtering features to, again, allow somebody to examine a large data set, particularly like a large set of unstructured data consisting of user-generated files, emails, chat documents, and so on and so forth. There are a number of other features in Investigate that really aren't sort of germane to this particular demo, but it's a very powerful by itself. Okay, so that covers what I wanted to show from an automation standpoint. Again, we went from, there was no click from when the user decided, I want to grab this data off of my suspect's endpoint, to when the analyst receives the email saying, hey, this spreadsheet is ready for you to review that risk scores all of that data. And that's the power of the automation engine. So for the last part of the demo presentation, we'll take a closer look at the machine learning capabilities, specifically around Nuix and NLP. Nuix actually has a couple of things going on right now in AI, as I guess everyone does, right? However, Nuix actually, to its credit, has been working on this for some time and looking at how to apply natural language processing to characterize unstructured text in particular. In addition to that, what's called Nuix owned, that's on this slide referred to as Nuix owned AI, ML, our natural language processing technology. We've integrated some open source models which allow us to do some very cool things in terms terms of searching unstructured text or searching text and searching images for concepts. And so that's what we refer to as semantic search, and that includes the ability to run, or an example would be, running searches. If any of you were at the recent Nuix conference, you saw the demo example, which is a search for the phrase, I'm pressed for cash, will return a whole bunch of phrases that are very similar to that, or maybe not, semantically very similar, but are getting at that exact concept. And that's a pretty exciting development. Again, using open source AI technology from Microsoft and a couple of others that's been integrated into Nuix. And then finally, we have customer BYO, which is something that we're looking at to make use of generative AI within the Nuix platform. And so the concept here is that our customers who want to use generative AI to summarize data can use their own access to engines like ChatGPT to pass unstructured data up, receive a generative AI summary of that, which then will get attached to the original item in the Nuix case. Okay, so we talked a little bit about the magnitude report. That's really the money kind of result of the NLP of the Nuix owned AI is this risk magnitude report. And that'll include basic characterization of the data around entities. An entity would be something like a selector in the intelligence community parlance, like a date of birth or driver's license number, as well as information about the file from its extension, so that all those things are included in magnitude reporting. But the magnitude report also gets us this risk score. So the way that works in Nuix is we're going to use the natural language processing interface to, first of all, apply out-of-the-box document type classifiers. So this product ships with hundreds of document type models to identify the various kinds of document types that are typically found in large enterprises. And so those include things like HR-generated items, maybe investigations, contract documents. You can see here, things like corporate travel policy. There are quite a few of these models that are built into the product. And so if I was using NLP to examine sensitive data, one of the first things I would do would be to look at the document type classifiers and select the ones that are important to me and that I care about. Topic classifiers are also available. And so this is not looking for like a particular document, it's looking for a topic. And so while we have one here for fraud, it's looking for people talking about the opportunity to commit fraud, feeling pressure to commit fraud, or expressing rationalization around committing fraud. And so there are phrases and training text that has been given to the AI engine to identify these things that are available to you. Cognitive expressions is another aspect of Nuix NLP, and a cognitive expression is a way of essentially combining regular expressions into more complex structures that allow us to look more precisely for strings, various strings of data. So that's the cognitive expression. The example here is looking for official use only, and doing that by combining a regular expression to look for the acronym FOUO with the text official use only. So one of my colleagues refers to cognitive expressions as regex on steroids.
We found in practical use reduction of false positives in PII identification of 6 to 1.
Yes, a much more precise way to look One of the things that you can also do with NLP is you can train it using example documents. So maybe there's a particular, if this was an intelligence community scenario, maybe I would want to look for, I was doing some kind of review task and I want to find any intelligence report that is related to a particular topic or country. And I could take, 4 or 5 of those and train the model on the full text of that and assign a weight to the different documents that I provide as part of the training. And this interface also allows me to not just provide blocks of training text, but also provide specific strings that I want to match against and include those as part of my model. And then finally, we would assign risk rules. So for example, in the this particular risk rule, we're looking at a classification marking for top secret, and it's going to receive a risk value of 0.95 relative to classification marking for FOUO, which I think it has got a 0.5. So those risk rules allow me to control, what that consolidated risk report looks like. The AI then applies the results of that scoring as tags to my Nuix case, and that results in the risk report. So the demo video will show a little bit of what this Nuix NLP interface looks like. So again, a web application, all part of the Neo platform, so you would navigate to this without having to authenticate separately, and since authentication is handled as a single user experience through Keycloak. And then, we're going to look at our own custom model here. So this is the creation of a topic type model for weapons at work. And I've added some training text to the weapons at work model here, and then updated it. And then we'll navigate from there. You can see just clicking down through over into the compound lexeme list, which will show me both my compound lexemes as well as regular expressions. And we can edit those here, create new ones using the no-code interface. And do the same thing with regular expressions. And I think the point here is that there's a very large number of out-of-the-box compound lexemes, particularly for PII identification. So probably if it's an account number you're looking for, any type of PII, the product is already going to do that for you out of the box. The risk rules then, we go into the risk rules and assign those based on our desires for how much weight, what weight we give each of our entities. And that's going to result in our risk score final report. I've got it sorted here by total risk score, so this is aggregate across all the different indicators that we're looking for. And I think we've mostly covered this. As I mentioned, though, you can jump from that risk report directly into Nuix Investigate, which gives you access to the full content of each of those risk scored files in the Excel sheet. Well, I appreciate your patience, and I'm going to wrap it up here with.
Thank you. Thanks for not giving up on me.
Next time I'm going to insist on a free-lunch
Yeah.
window. But
Earlier audience.
so we talked about, I didn't want to I wanted to do justice to Carrie's points a little bit around getting proactive and zero trust. And there's a couple of ways to get proactive with this stack. One of them is in threat hunting. So with the user activity monitoring platform, we can actually look for indicators of insider risk or cyber threat, based on custom ways that we create for hunting purposes. So think of, reading threat intelligence about Monero, the use of Monero as a tool, and wanting to find, do I have any users who are actually like accessing Monero or interacting with Monero in my enterprise? You could do that with this. Maybe you want to generate a report and say, how many people do I have who are doing anything with cryptocurrency, and what does it look like they're doing with it? That becomes possible with this kind of UAM approach. When it comes to sensitive data discovery and creating risk rules and detection entities, if you get that right on the investigative side, you know, if in your investigative workflow, you're forced to say, okay, sensitive data in my enterprise looks like this combination of classification markings and intellectual property indicators and other things, then we can turn around and be proactive about that, about using that to clean up sensitive data on shared drives and you know, on servers and other places where maybe it shouldn't be, on individual users' workstations. And then finally, you have the ZTA capability area of tagging, where if we can get to the point where our AI is smart enough to say with high confidence that this particular file, you know, should be classified maybe at a particular level, or pertains to a specific program, and we're confident in that, then we can we can create a tag that then we want DLP and we want security monitoring tools to recognize and take action on. And that's where this last sort of aspect of proactivity comes in, is applying those tags.
Yeah, one of the interesting sort of aha moments we had when thinking about applying this to a zero trust data preparation use case, obviously not why it was built, it wasn't, you know, the purpose behind building it, but an outcome of the capability. If you think about things where, you know, as we talked about earlier, being involved in some programs around full disclosure and other things, the specific stamp, if you will, on a PDF doesn't necessarily actually define the sensitivity of an item depending on what's in it. And, you know, an example I would use is, you know, two independent pieces of information don't require classification, but when you have those in the same document, it does. And what's really interesting with the level of, I use the term mathematics, applied to natural language within the cognitive AI capability, to be able to take things like, for example, we're concerned with bodies of water. So it's going to find, you know, you would expect river, lake, creek, stream, those sorts of things.
Right.
Data link would not be a positive hit because it knows the difference between a data link and a body of water.
Filters that out.
Or, for example, you're talking about golf and you're interested in a car, Volkswagen Golf. And it talks about, yeah, we played a round of golf. It's not going to include that as a hit because it knows the difference. And so if you apply that sort of, again, mathematics, right, because you're turning text in the English language or whatever language, you're turning that language into math and being able to do the neural network spatial mapping of those ones and zeros and all that math, it gets you to a really interesting capability in being able to identify, again, for a domains, not necessarily data scientists, to be able to score their stuff based upon some samples and say, yes, this is risky, this is not, because I know in this program, mention of that word or that systems or Aegis, right, whatever it is, mention of that with this, that's a no-no. We need high risk. And so it adds such an additional level of capability to the organization to understand where your sensitive things are.
That's great. Number one, you have to know what you have, know what's important. You know what I mean? DoD is so reactionary when it comes to incident management. We don't do anything until it's triggered something and we're already in defense mode, fighting the fire. So something like this, I can smart ahead of it and puts you quicker to the incident, closer to the incident. I mean, it's really important. And there's human behavior tracking and other things like that, where you got the violence in the workplace and other things, that's the insider threat, that's monitored. Ideally, it would be managed at the security personnel security level and stuff like that, where they have, because not everybody's aware of somebody's personnel at home issues and other things, but stuff as security, as a security manager becomes aware of it, and it gets flagged in their security profile and some other things. And it's up to coworkers to keep an eye out on each other too, so, not in a bad way, but in a good way, you know.
Right. Those indicators have to be like put together with other data.
Yeah, it's key. It's a powerful tool in us.